Good morning, students. This is Maithili, Assistant Professor, Department of Mathematics, St. Anne's Arts and Science College. Dear students, today we are going to see the next method, that is another method, reduction of order. Reduction of order. Here we consider the methods of solution of differential equations of second order with variable coefficients. In this reduction of order, we have to consider the second order differential equation. For the last method, we saw the first order differential equations only. But in this method, we are going to see the second order differential equation. That is, we consider the methods of solutions of differential equations of second order with variable coefficients. So first method is dependent variable missing. That is dependent variable missing. What is a dependent variable? If y is not explicitly present, the first type, if y is not explicitly present, then the equation can be written as f of x comma y dash comma y2 dash is equal to 0. If y is not explicit, suppose that is nothing, but if y is not present means the equation can be written as f of x comma y dash comma y2 dash is equal to 0 and mark it as equation number 1. We introduce a new dependent variable p. So in this method, we have to introduce one new dependent variable that is called p. That is, we have to introduce y dash is equal to p. We have to introduce y dash is equal to p. So y dash is equal to p means y2 dash, that is we have to differentiate this y dash with respect to x. That is y2 dash is nothing but dp by dx. So you have to introduce one dependent variable p. So you have to mark it as y dash is equal to p and differentiate y dash. We get y2 dash is equal to dp by dx. Mark it as equation number 2. Now, see the first equation. The first equation can be rewritten as what is called first equation? F of x comma y dash comma y2 dash. So, in the place of y dash and y2 dash, we have to substitute p and dp by dx. Right? So, the first equation becomes f of x comma p comma dp by dx is equal to 0. Okay, guys, this is marked it as equation number 3. So, and we solve equation 3, we get the solution. This is the first method. That is, independent variable is missing. That is, listen, if y is not present means we have to, y is not present mean we have to write the equation as f of x comma y dash comma y2 dash, and we have to introduce one new variable p, that is y dash is equal to p and y2 dash is equal to dp by dx. So the equation 1 can be written as f of x comma p comma dp by dx is equal to 0. And we solve the equation 3, we get the solution. The next method is independent variable missing. That is independent variable. That is what is called independent variable x. If x is not explicitly present, suppose if x is not present, the equation can be written as, that is, for the y terms, y is not explicitly present, we take it the function as f. For the change, the second type, we take the function as g. Suppose g of y comma y dash comma y2 dash is equal to 0. For in this condition, x is not present. So this is second type. If x is not present mean the equation can be written as g of y comma y dash comma y2 dash is equal to 0. Mark it as equation number 1. So here the same, we have to introduce a new variable p. So y dash is equal to p. So we have to differentiate y2 dash. That is, we have to differentiate y dash with respect to x. So y2 dash is equal to dp by dx. Okay. So here the x is not explicitly present, right? So we have to rewrite dp by dx as dp by dy into dy by dx. Clear, girls? Listen carefully. In this condition, x is not explicitly present. So the condition equation can be written as g of y comma y dash comma y2 dash is equal to 0. We have to introduce one new variable p. So y dash is equal to p. And y2 dash is nothing but we have to differentiate p with respect to x. So that is dp by dx. But x is not present. So we have to write dp by dy into dy by dx. So y2 dash can be written as dp by dy into p. So dy by dx, nothing but p, no. So y2 dash is equal to dp by dy into p. So now rewrite the equation 1 as g of y comma p comma p into dp by dy is equal to 0. And we solve this equation, we get the solution. This is the condition for the reduction of the order. For the reduction of the order, the solution is of the second order differential equation with variable coefficient. And there is two types. One is dependent variable missing, that is y is explicitly missing, explicitly not present. And second one is independent variable missing, that is x is not present. So in this two type, how can we solve? This is the method. See the problem. By reducing the order, see the problem, see the question. By reducing the order and solve the equation x y2 dash minus y dash is equal to 3x square. Listen carefully. By how to reducing the order and solve the given equation is x y2 dash minus y dash is equal to 3x square. See the equation, girls. X y2 dash minus y dash is equal to 3x square. So in this equation, y is missing, right? We get only y dash, y2 dash, but y term is not present here. For this is of first order. So write the solution. First write the given equation. Given equation is x y2 dash minus y dash is equal to 3x square. Mark it as equation number 1. So see the equation. In this equation, y is not present, right? So here y is not present. So we have to introduce a new variable, new independent variable p. So we have to introduce p, that is y dash is equal to p. So y dash is equal to p means y2 dash is equal to dp by dx. Clear? Now write y dash is equal to p and y2 dash is equal to dp by dx in equation number 1. And see the equation 1, x into dp by dx. Right, x into y2 dash. So write y2 dash is equal to dp by dx. So it becomes x dp by dx minus y dash. In the place of y dash, substitute p. So minus p is equal to the right hand side is 3x square. Now in this equation, divide throughout by x. So we get dp by dx minus p by x is equal to 3x. What we get? dp by dx minus p by x is equal to 3x. Now see the equation which is linear in p and x. This is a linear equation. In the what are the variable? Two variables, that is p and x. So it is in the form of, what is in the form? dy. We know the equation, linear equation form, dy by dx plus py is equal to q. Right. Here p is already present. So we have to introduce one more new variable, that is ay. Instead of p, I introduce a. That's all. So dy by dx plus ay is equal to b. There is nothing but some differentiation. That's all. So in the place of a, we get minus 1 by x. Clear, girls? dp by dx minus p by x is equal to 3x. For it is in the form linear equation p and x. So in the place of a, we get minus 1 by x and b is equal to 3x. And what is the integrating factor formula? E power integral p dx. Here p is nothing but a. So e power integral a dx. So e power integral minus 1 by x into dx is equal to e power minus log x. So e power log x power minus 1. So e log getting cancelled, we get only 1 by x. So integrating factor is equal to 1 by x. What is the solution? We know that solution. Integrating factor is p into integrating factor is equal to integral b into integrating factor into dx plus c. So p into, we get the integrating factor is 1 by x, integral 3 into 1 by x into 3x. Okay, 3x into 1 by x into dx plus c. So the left hand side we get p by x. The right hand side we get 3 into integral dx. Integration of dx is nothing but x. So 3x plus c. So we get p is equal to 3x square plus cx. Now we have to put the variable p is equal to dy by dx. What we write? Y dash is equal to p, no. So you have to write p is equal to, y dash is nothing but dy by dx is equal to 3x square plus cx. Therefore dy is equal to, just cross multiply, we get 3x square into dx plus cx into dx. Now we get integrating. After integrating, we get y is equal to 3x cube by 3 plus cx square by 2 plus a. So here already c is constant. So you have to introduce one more new constant, that is capital A. So that we get y is equal to y cube minus c by 2 x square plus a. Then y is equal to x cube plus we have to interchange c by 2 as c1. Okay, so c1 x square plus a. This is the solution. See the next problem. By introducing the order and solve the equation y2 dash plus k square y is equal to 0. y2 dash plus k square y is equal to 0. See the equation. In this equation, which term is missing? X is missing. Right, girls? So, first write the given equation. Y2 dash plus k square y is equal to 0. Mark it as equation number 1. Here, X is not present. So, introduce a new dependent variable P. So, y dash is equal to P. And what is y2 dash? We already wrote. Y2 dash is nothing but dp by dy into P. We already written here. Y dash is equal to P means y2 dash is equal to dp by dx. dp by dx can be written as dp by dy into dy by dx. dy by dx is nothing, P. So, y2 dash is equal to dp by dy into P. Now, write the first equation. Just write y dash and y2 dash in first equation. So, we get P into dp by dy plus k square y is equal to 0. So, we get P into dp by dy is equal to minus k square y. So, P dp is equal to minus k square y dy. Okay, the simple integration. So, we get after integrating p square by 2 is equal to minus k square into y square by 2. Again, we have to introduce k square. See, why we have to introduce k square, a constant in terms of square? See, all the terms in square. So, we have to introduce k square as constant. See here, p square by 2, k square again, y square by 2. So, all the terms are in square means we have to introduce the one more constant. Constant is also square. So, you have to introduce again k square. So, p square is equal to, just multiply by 2. We get p square is equal to minus k square y square plus 2k square. Mark it as equation number 2. Again, we have to replace p. P is nothing but y dash. That is dy by dx the whole square is equal to minus k square y square plus 2k square. Now, dy by dx the whole square is equal to take k square outside and just replace k square into 2 minus y square. So, by removing the square, you have to introduce the square root, right? By removing the square term, we have to introduce square root on both sides. So, the term becomes dy by dx is equal to k into root of 2 minus y square. The next step, just separate the variables y terms and k term, x term. For dy divided by root, see, the 2 inside the square root, the 2 alone can be written as root to the whole square, right? Root to the whole square is nothing but 2. So, root of root to the whole square minus y square is equal to k dx. Now, integrating dy divided by root of root to the whole square minus y square is equal to k into integral dx. So, what do we know the formula? Integral dx by root of a square minus x square. That is nothing but sine inverse of x by a. So, same one. So, integral sine inverse of x. In the place of x, we have y. In the place of a, we get root 2. So, sine inverse of y by root 2 is equal to kx plus c. That is the solution. So, here the two homework sums are given, girls. The first sum C, x y2 dash plus y dash is equal to 4x. For in the first homework sum, which term is missing, ma? Y terms is missing. So, this is same as in problem number 1. See the second problem, y2 dash plus y dash the whole square is equal to 0. So, in the second sum, x term is missing. This is same as in problem number 2. Okay, so just do the two problems. If you have any doubts, you can ask me. I will clear your doubts. Right, girls? Thank you.